Welcome back, everyone. Mr. Wakefield here with the end of Chapter 9, at least for now. This is the last section of Chapter 9. We'll come back and do Section 9.6 later. Right now, 9.7 is the final section that we'll see for now for that chapter. Now, what we're going to be looking at here is fractional exponents. What happens, you guys, when an exponent is a fraction? How can you take a number like 81 to the 1/2 power, for example? How do you multiply something 1/2 of a time? Well, you really don't, right? I mean, that's kind of not really normal, right? There still is a meaning to it, though, and it's something that allows the other exponent rules that we learned in the past to make sense. Okay, let me show you what I mean here. You don't have to write this down. This is just going to help you make better sense of it. So 81 to the 1/2 power, right? Let's take that. Now, as you guys know, if I put a bracket around that and then put an exponent on the outside, we learned back in Chapter 2 that when you have a term in a bracket taken to a power, that means that you multiply the exponents. Okay, so this would actually be 1/2 times 2, which is the same thing as 1/2 times 2 over 1. We know now from Chapter 8 that when we multiply fractions, you can cross-cancel. And so we end up with 1 over 1, which is 1. And so that means that this would be 81 to the first power. And of course, 81 to the first power, since it's to the first power, it's just 81. Okay, so what we got here is we got something to the second power, this 81 to the 1/2, which we're still wondering what it's equal to. We don't know what 81 to the 1/2 power is equal to yet, but we do know that if we take it to the second power, it's equal to 81. Okay. We also learned in the last section that when we take the square root of 81 to the second power, we learned in 9.5 that that's also equal to 81. So it's not a surprise that when you have something to the 1/2 power, it's the square root of 81. So 81 to the 1/2 and square root of 81 are actually the same thing. And that's what this rule is trying to tell us here. It's saying that if you have a fraction exponent where there's a 1 on top, and if the top of the fraction in the exponent was not 1, that would be different. That's where you would use this rule down here, separate rule. But if the top of the fractional exponent is 1, then the bottom, if it's 2, then it's a square root. Because remember, when you have a radical with a little 2 here, that's a square root. You don't have to write the 2 when it's a square root. Let me zoom in there. Okay, you don't have to write the 2, okay, but that's what it means. So if it's 1 over 2, then that means square root. Okay, so what we realize now is that as we go down here, this is the square root of 81. Okay, because they both equal to 81 when you square them, and so it makes sense. All right, so anything to the 1/2 power, you guys, is equal to the square root of that thing that you're taking to the 1/2 power automatically. Okay, so it makes sense then, as we go over to the next one, if you have instead of 1/2 power, you have 1/3 power, that instead of it being the square root, it's going to be the cube root. Okay? I'm sorry, why am I circling this? I need to finish that off. Okay, excuse me there. It is still the square root of 81. I didn't make a mistake. I just didn't finish the problem. Okay? Once you put it in radical form, as the directions tell us to do, and you do have to do that, that's very important, okay? You will not get full credit on either a homework problem or a test question unless you do that. The reason why I require you to put it in radical notation is because the scientific calculators that I told you you're allowed to use, okay, if you know how to use them in a certain way, you could actually type this into the calculator and it'll give you the final answer without you having to do any work. But I need you to do the work so that you can prove to me that you know the relationship between a fractional exponent and a radical. Okay, whether it's a square root radical or a cube root radical. So it is required that you put it in radical notation first. Then once you do that, then you go ahead and figure out what it's equal to. We know that the square root of 81 is 9. Now we're done. Okay, so put it in radical notation, then compute it, and you're done. Same thing with the next one. Put it in radical notation and then compute the cube root of 8, which, as you know, is equal to 2. Okay, so again, reviewing here, 1/2 power means square root, 1/3 power means cube root. In other words, the denominator is the thing that tells you what kind of root you have. If it's 2, it's square root. If it's a 3 in the denominator of the fraction exponent, then it's a cube root. What happens, and we haven't seen this before, but we'll go through it carefully. What happens if it is 4 on the bottom? 1/4. Okay, well, as you can imagine, that's going to be the 4th root. And 81 is the number you're taking to that power, so the 81 goes on the inside. Now, again, we haven't seen 4th roots before. So let me just go over those. This is the only section you're going to see them in, but they're very similar to square roots. Okay, not cube roots, but square roots. Okay, as you guys know from the section 9.1, the way you figure out a square root, if you're just figuring it out, not simplifying the radical, but just figuring out what the root is equal to, you figure out the positive number so that when you square it, it's equal to the inside of the radical. Okay, that's why this is equal to 4. 4 is the positive number so that when you square it, it's equal to the inside of the radical. 4th roots work the same way. Okay, you are figuring out what positive number, and it's got to be positive, just like with square roots. What positive number do you take to the 4th power? And I say 4th power instead of 2nd power this time because this is a 4th root. Okay, 4th root means you're figuring out what is taken to the 4th power to equal, in this case, 81, because 81 is underneath the radical. So you can see it's the same thing as it was before. It's just that now the exponent outside the bracket is a 4 instead of a 2 because it's a 4th root instead of a square root. Okay, so what positive number, you guys, is taken to the 4th power to equal 81? Well, I know it's not 2 because 2 to the 4th is 16. How about 3? Okay, as it turns out, that's what it is, because if you multiply 3 4 times, okay, 3 times 3 is 9, 9 times 3 is 27, and then if you multiply 3 a 4th time, 27 times 3 is 81. So the answer here is 3. Okay, so very rare. You're only going to see the 4th root in this section, but that's how it works. Very similar to square roots, except for the exponent here is 4 instead of 2. But you're looking for the positive number, just like square roots. All right, let's keep going here. Next one here. Remember, you guys, when you have a bracket next to an exponent, whether it's a fraction exponent or just a regular exponent, okay, if you have a bracket next to it, then the entire thing inside the bracket is taken to that power. Okay, so that means that the entire thing inside the bracket goes inside of the radical, because that's the rule, you guys. The rule is whatever's taken to the fraction power, that whole thing goes inside of the radical. Okay, 81 was taken to the 1/2 power, you put 81 inside the radical. 8 is taken to the fraction power, you put 8 inside. So if you have a bracket taken to a fraction power, the entire bracket goes on the inside. You don't need to bring the bracket in there with it because it's just a bracket only. It's not like there's a bracket in there and something else outside of it all going inside the radical. It's just the bracket that goes in there, so the bracket can be discarded. Okay, you don't need to keep it. And then since this is to the 1/2 power, that means that this is a square root. You could put the 2 here if you want in the V here. You could put a little 2 there, okay, just like you would put a 3 there if it was a cube root. But as you guys now know, if it's a square root, the 2 does not need to be written there, okay. We know that whenever there is nothing written there, it automatically means that there's an invisible 2 there. That's how square roots work, right? So this is the square root of 16 over 121. Now, as we learned back in 9.1, okay, when you have the square root of a fraction, if you know what the square root of each of the two numbers is, that creates a brand new fraction. Just make sure it's a positive answer, because square roots, okay, a square root radical is supposed to be equal to a positive answer, isn't it? Okay. And so, what is the square root of, sorry about that, there it is. What is the square root of 16 and what's the square root of 121? Well, we actually know what those are, right? The square root of 16 is 4. The square root of 121 is 11. And again, just make sure your answer is positive. It is, okay? 4/11 is a positive fraction. And so, there you go. Okay, now, notice in this problem here, for the first time, we have a fraction exponent where the top of the fraction is not a 1. It's a 2 in this case. All right, in the next problem, it's going to be a 4. Okay, what do you do when that happens? This first step you don't have to write down, but I want you to see where the formula comes from. So again, you don't have to write down the step if you don't want to. But basically how it works is like this. You take the 2/3 and you split it up into two parts. Okay, you put the 121 on the, or pardon me, the 125, you put it on the inside of a bracket. Okay, and then you take the 2/3 and you split it up like this. You take the 3 and you put it with a 1, where the 1's got to be on top and the 3 stays where it's at on the bottom. Okay, and then you put the numerator on the outside. The reason why I did this is because, as I just reminding you of a few minutes ago, when it's written like this, when you have a term inside of a bracket and then it's taken to a power, you multiply those exponents if you want to figure this out. So that confirms that this is the same thing as the original problem, because we know that 1/3 times 2 is equal to 2/3, isn't it? Isn't 1/3 times 2 equal to 2/3? And it's the same thing, like if this had been 2/5, for example, you guys. If it was 2/5, then you would say 1/5 times 2. Okay, in other words, 1/5 on the inside, 2 on the outside. Okay, both of them exponents, 1/5 and 2. Okay, if this had been 3/4, you would say 1/4 and 3. You see how I'm keeping the denominator on the inside with a 1 above it, and then you're putting the numerator outside by itself. Okay, so you can see then that these two things are the same, and that's important because it shows us where the other formula at the top of the page came from. So again, you don't have to write down this step. You can jump right to this next step that I'm about ready to write, which brings us to the second formula at the top of the sheet. Okay, but let me show you how we get that formula just by looking at this. Instead of just looking at the top of the worksheet, let me just show you how to convert this to radical notation like the directions tell us to. What would be 125 to the 1/3 power if we converted that to a radical? As the rule at the very top tells us that, right? And we've been using that rule in the last few problems. 125 to the 1/3 power would be the cube root of 125. So on the inside of the bracket, I would write the cube root of 125, like this, okay, to the second power. And then you can see now that this thing right here, this part you do need to write because it's where you convert it to a radical, that is the same thing as the secondary rule up here, okay? The cube root of 125 to the second power. In other words, you can see that it's telling you that the numerator goes on the outside, just like I did here in that step that I told you didn't have to write down, okay? When you have a fraction exponent where the top of the fraction is something other than 1, you put that number on the outside, okay, And then the denominator, again, as it was before, the denominator, as always, becomes that little number you put inside the v of the radical that tells you what kind of root you have, whether it's a square root, a cube root, a fourth root, whatever it may be. Okay, that goes there. And you can see that that's what happened. Let me zoom back in. All right. The denominator went inside the v. And since the numerator was not equal to 1, we made a bracket with a 2 on the outside. That's exactly what the rule at the top is telling us to do. Yes, we have this alternate rule here as well, which also works in this case, but this rule is a lot easier to use because this rule over here sometimes makes the numbers really big when you try to figure out what it's equal to. So especially in this problem that we're working on right now. So definitely use this rule for now, okay? This one. It says or, meaning you could theoretically use either one of these two things here to be equal to the fraction exponent. But like I said, this one's easier. Okay, use that. Okay, so what do we get here? Now that I've converted it to radical notation, I compute this, and remember, there's no variables here, so we do order of operations to figure it out. And we know that, as we've talked about before, radicals come before exponents. Radicals come before exponents. Maybe we didn't talk about that actually, but radicals, radicals do not necessarily, sometimes they do. Depends on how you were taught this, but what I meant to say was parentheses come before exponents. Parentheses come before exponents. And so just like when we've said in the past with a PEMDAS, okay, please excuse my dear Aunt Sally, that's your rules for order of operations. Parentheses come before exponents. And since there's a radical inside of the parenthesis, we got to do the radical first and then the exponent. Okay. So that radical inside the parenthesis is 5. So now we're done with the parenthesis step. Again, when the inside of a parenthesis is just equal to a single number, okay, you're done with the parenthesis now. Now you move on to the exponent and you get 25. Okay? All right, now, what do we do, you guys, when we have negatives here? We've seen negatives before as they get mixed in with exponents. All right, now we're going to see them get mixed in with fraction exponents. It's basically the same thing as it was before. Notice here that we have a negative and then a number, and then that number's taken to this power. It's just that now it's a fraction power. Okay, this is similar to this problem here from back in chapter 2 when we were doing exponent rules. See how we got the negative, the number, and then the exponent, but there's no parenthesis like there is, say, in this problem over here. Okay, and so as we learned, when you have a negative and then the number and then the constant number and then the exponent, that means -1 times 6 squared. Okay, when you have a negative at the beginning of the problem, that can be interpreted as -1 times when you have the negative and then the constant number and then the exponent with no parenthesis there. Okay, you can be interpreted that way, and that's the best way to interpret it. So in a similar way, this then would be what? It would be -1 times 27 to the 4/3. You don't need to convert it to radical notation first. Okay, you want to get that negative out of the way there. So when it's written like this with the negative and the constant number and the exponent in that order with no parenthesis, separate the -1 first, then do the radical notation, and you'll notice now that the thing that's being taken to the 4/3 power, the thing that's being taken to the fraction power, in other words, is not -27, it is +27. Big difference. And so because of that, when we write it out, we're supposed to write the little 3 inside the v because that's the denominator, and we're supposed to write the 4 on the outside of the bracket that we create whenever the fraction exponent does not have a 1 on the top. Whatever it is, you put it on the outside. But then what goes inside the radical is not -27, it's +27 because The thing that's being taken to the fraction power, again, is not negative 27, it's positive 27. So whatever is being taken to that fraction power goes inside of there. Do not put negative 27 in there, but just 27. Now again, going back to PEMDAS here, order of operations, and now that I've done my radical notation, it's time to do order of operations. We do parentheses first. Cube root of 27 is 3. After that, we do exponents. 3 to the 4th is 81. And then after that, we do multiplication, right? PEM, parentheses, exponents, multiplication. Final answer, negative 81. Okay? All right. So that's what happens when it's written like that, with the negative and the constant number and the exponent in that order with no parentheses. What if you have a negative exponent, though, like we have here in problem G? Okay, we've seen that before. It's not going to be any different here about how you deal with the negative exponent. Okay, again, back in that same chapter, chapter 2, we learned the negative exponents when you have just a number taken to a negative power. Not one of these bigger problems where you got negative exponents mixed in with a whole bunch of stuff. I'm not talking about that. Just when you have a constant number taken to a negative power, this is what you do. Okay, you put a 1, and then underneath the fraction bar, you take the same number that was taken to the negative power, and it's now taken to the positive power instead. Let's do that same thing here. So 100 to the negative power becomes 1 over 100 to the positive power, like that. Okay? So that's what we do here. Let's review that for a second here. If you've got the negative in front, okay, with the negative and the constant and the exponent with no parenthesis, that setup, okay, whether it's that kind of negative or if you've got a negative exponent, okay, go ahead and deal with those things first, all right, before you do the radical notation step, all right? So we know what to do in this situation with the negative. We now know what to do when the exponent's negative. We do those things first, then you do the radical notation after that. It's just a lot easier that way. Okay, you don't run into any issues with negatives kind of throwing you off and everything. All right, so do it that way, and then it's a lot easier to do the radical notation. Now, remember, the 3/2 is the exponent for what here? It is not the exponent for 1 over 100, okay? It is just in the denominator, so it's just 100, not 1 over 100, but just 100 only that's taken to the 3/2 power. And so therefore, what we do is the 100 goes inside the radical, because that's the thing taken to the fraction power. And then the 2 tells us that this is a square root. You don't have to write the little 2 there like we talked about when it's a square root. It's automatically implied that there's an invisible 2 there. But then the 3, since it's the numerator of the fraction exponent, that goes on the outside of the bracket like that. And now I have it in radical notation. Then I do order of operations. And remember, when you have just a single fraction as your problem, with no variables or anything, the way to do order of operations is to figure out what the top and bottom are equal to, and then you put it in lowest terms, if it isn't already in lowest terms. Now the top is 1, that's not going to change, all right? There's nothing to compute there. But here, down here, we got to do parentheses before exponents. Square root of 100 is 10. 10 to the 3rd is 1,000. Okay. Okay, so, and then that's already in lowest terms, so we're done with that. All right. What happens if you now have a negative in front with no parenthesis or anything, just like we had in this problem here, the negative, the constant, and the exponent with no parenthesis, but you also have a negative exponent too. Okay, in other words, problem H is like a combination of F and G both, where it's got both of those kinds of negatives there. All right, the negative in front and the negative exponent as well. What you do is you do both things that we did in F and G. Okay, the negative in front causes you to have to do that right there. When you have negative, and I'm sorry, I know I'm saying this a lot, but this is something that a lot of people miss. Negative, constant, and then exponent, you got to say -1 times, all right? Assuming there's no parentheses there. And then for the negative exponent, and you could have done this on the same step as the -1 on the outside, but I'm just doing one part at a time here. The negative exponent is this, isn't it? 1 over 16 to the 5/4 here, okay? So you don't have to write it. You don't have to write this step right. You could just do both things all at once here. When you got both of those types of negatives there, the one in the front and the one in the exponent. Okay. But this is what we need to end up with. So again, we're dealing with the negatives. All right, whether they're in front or in the exponent, we're dealing with them just the way we learned in F and G. Okay, it's just that we have both of those negatives here. Now that we've taken care of those negatives, just like we learned in F and G, now we do the radical notation, okay? And then we do the order of operations and we're done. So you deal with the negatives, you do the radical notation, then you do the order of operations. That's basically what these problems with the fractional exponents are all about, okay? So remember, just the 16's taken to the 5/4 power because the exponent is just down in the denominator only. It does not affect this one here. It does not affect the -1 here, just the 16. So what do we get? Let's see. 5/4 means that, first of all, the 16 goes inside the radical because that's what's being taken to the fraction power. But the 4 goes on the V part of the radical there. It tells us what kind of root we have. And then the 5, since it's the numerator, it goes on the outside of that. All in the denominator, though, because the 16 5/4 is all contained in the denominator. It's all isolated there. So keep all of that in there. Do not allow the 5 to go up to the numerator or the 4 either, okay? When you have something taken to a power and it's all in the denominator, then that means that when you convert it to a radical notation, again, it has to all stay in the denominator. Now we do order of operations, and when you have -1 times a fraction and that's all you have is just the -1 in the fraction, the way to do that, there's more than one way to do it, but the easiest way to do it is to first of all figure out the fraction just like we did in the last problem. Okay, the way you figure out a fraction, if you want to know what a fraction is equal to, is you figure out what the top and bottom is equal to first. Okay, we know the top is 1. We know that the bottom parentheses go before the exponent. The 4th root of 16, you guys, what is that? The 4th root of 16 is the positive number, like we talked about with 4th roots. It's the positive number that you can take to the 4th power to equal the number on the inside of the radical. We know that that's 2. Don't choose -2 because remember, 4th root radicals, just like square root radicals, they've got to be equal to a positive answer. Okay, so this is then 2 to the 5th. We then do the exponent and we get -1 times 1 over 32. Okay, and that's already in lowest terms. So we're done with the fraction. We figured out what the top and bottom were equal to. We tried to put it in lower terms. It doesn't go into lower terms. All right. So then when you multiply that by -1, anytime you multiply any fraction by -1, and that's what you do last here, is you multiply by the -1 after you figure out what the fraction is. But a fraction times -1, anytime you multiply anything by -1, all it does is change the sign of what you're multiplying. So positive 1 over 32 is now -1 over 32 because the -1 just changes the sign. Okay, so when you have -1 times a fraction, figure out what the fraction is equal to. and then just multiply by -1 at the end. Okay, so what I'd like you to do right now is try problems 1 through 5. 4 and 5 are on the second page here. Okay, at the top of the second page. 1, 2, and 3 are at the bottom of this page. All right, you should be able to do those. Remember what we talked about with negatives. All right, you should be able to do those 5 problems. Please try those. Hit the play button, and then we'll take a look at those answers. Okay, you guys, for 27 to the 2/3, because the numerator is not equal to 1, we're going to do that rule, the second rule, where you have the bracket, and then you put the numerator on the outside, like always. The denominator becomes that little number that goes inside the v. We call that number, by the way, the index number, if you're wondering about the name of it. But the denominator does go there, and it tells us what kind of radical we have. It's a cube root because there's a 3 due to the fact that the denominator is 3. And so it's the cube root of 27 with the 2 on the outside. Then once we set up the radical notation, which is required, then we do order of operations to figure this out. Parentheses first, we get 3 squared because the cube root of 27 is 3. Final answer, 3 squared is 9. Okay, so that is number 1. Number 2, when you have a fraction exponent, again, deal with the negatives first. Since it's a fraction exponent, we do that thing where we flip it over to get rid of the negative, okay, and it makes it easier to do the radical notation now. So do that first, then do the radical notation after you deal with the negatives. Since the 1/3 and the thing that's taken to the 1/3 power are all in the denominator, keep that radical notation part in the denominator only. The 1 is separate from that. And then, write that out, and then go ahead and do the order of operations last, like usual. And so, doing the radical, or we already did the radical notation, but doing the order of operations, we got to figure out what the top and bottom are equal to. The top obviously is 1, but the bottom is equal to 4. The cube root of 64 is 4, right? Because 4 to the 3rd is 64. So the cube root of 64 is 4. That's number 2. Okay. Number 3. If you've got a negative followed by the constant and the exponent with no parentheses, as we talked about, we write it like this: -1 times the constant with the exponent still there. That separates the -1 from what's going to be the radical notation here. All right, because we know that the 1/2 is being taken, the 1/2 is telling us that because of how this is written, only 64 is taken to the 1/2, not -64. And so that means that the 64 goes into the radical, not -64. This is one of the biggest mistakes that people make, you guys, is that they see this problem and they think that it's supposed to be -64 inside the radical, and then they say, oh, wait a minute, we can't have the square root of a negative number. This must be one of those problems that has no answer, that's not a real number, like we talked about in 9.1. Well, that's incorrect. That is not correct because, again, it is not -64 that's taken to the 1/2 power. It's positive 64. The -1 is separate. Okay? Watch out for that. Make sure that you know this, okay? You know this setup. Okay, now I've done the radical notation. I now do order of operations. Radicals come before multiplication. Okay, as I mentioned earlier, radicals, depending on how you learned it in the past, radicals could either be in the exponent category or in the parenthesis category. But either way, they come before multiplication, don't they? Because the P and the E in PEMDAS are before M. And so no matter which way you look at it, radicals come before multiplication. Okay. -1 times 8. So in other words, I figured out the radical first, then I do the multiplication. Final answer is -8. Let's move on over to the last two problems on the second page. You can see here that this is another problem where you got the negative on the outside with no parentheses. We do that -1 times setup again because of how it's written. Okay, and then now that we've dealt with the negative, we now do the radical notation. 4/3 means that it's a cube root with the 4 on the outside. Okay, numerator goes on the outside. Denominator tells you what the root is. Then you do order of operations. That means parentheses first, then the exponents, then the multiplication. Parentheses is equal to 2. The exponent is equal to 16. And finally, the multiplication is equal to -16. Okay, that's number 4. Finally, number 5. We have a negative in both the front and the with no parenthesis again. That makes a big difference. Okay. Remember that the reason why I keep on saying the parenthesis is because if you had, for example, -5 to the second with the parenthesis, then it is not 5 that's taken to the second power, it's -5. Because when you have the parenthesis next to the exponent, the entire parenthesis is taken to that power. But when it's written like this, then the negative is separate, right? Okay, so that's why I keep on mentioning that there's no parenthesis there and it makes a difference in everything. So negative, constant, exponent with no parenthesis, all right, that's when we do the -1 thing. Then because we have a negative exponent, we do this thing right here. Again, you can jump right to this step. You don't have to write down this step first. Just make sure you know how to write this when you have both of those negatives there. Okay. So now I've dealt with the negatives, the negative exponent, the negative in front. Now I do my radical notation. Then I do my order of operations to finish this thing up. Okay. So that would be what here? Got to figure out when you have -1 times a fraction, and that's all you have is -1 times a fraction. Again, as we said on the front, on the first page of this section, you need to figure out what the fraction is equal to first. Then you multiply by -1 at the end. The fraction is going to be 1 on top. The bottom is going to be parentheses first. That would be 5 to the third. Then you do the exponent after that, because exponents always come after parentheses, right? Okay. And so that gives me 125 on the bottom there. Now that now that I know what the top and bottom of the fraction are equal to, I could put it in lowest terms, but it already is in lowest terms. So then I multiply by -1. The final answer is -1 over 125. And as we talked about before with negative fractions, it doesn't matter as long as there's just a single term on the top and bottom. It doesn't matter if you put the negative on top, negative on the bottom, or a negative in front. They're all the same answer. They're all equal. They're all the same. Okay, as long as there's just a single term on top and bottom. If there's more than one term on the top and bottom, that's different. But since we just got single numbers on the top and bottom, and since the answer is supposed to be negative because we have a positive fraction being multiplied by -1, so that's going to change it to a negative answer. But negative answer, those negative signs could be in any one of those three places right there. You're fine no matter which of those three answers you give. Don't worry. Okay? So just wanted to clear that up as well, remind you of that. All right, so that concludes fraction exponents, section 9.7. Let me know if you have any questions about that. Okay, so we'll be coming back actually in the next video with the beginning of chapter 4, and we'll be talking about graphing in particular. Although that won't be the only thing, but that'll be the major thing. But this is it for chapter 9 for right now anyway. So you have a good day. Let me know if you have any questions about it, and take care.